Hi, and welcome to DAC 2010. Today we're going to show a short demo of Polyteda's PowerLVS integration within AWR's Analog Office design environment. Polyteda's PowerLVS is a sign-off LVS product architected to handle all of today's designs effectively and efficiently, from the most simple to the most complex. What you'll see today is the PowerLVS runtime flow within the Analog Office environment. You'll see probing between schematic and layout views, and you'll see the PowerLVS debugger being used to report and locate real errors within a real design. Let's start by taking a look at how PowerLVS can be used to locate shorted nets within a design. Let's start by opening a design in Analog Office. By choosing a circuit design, then choosing View Layout, we can bring up the corresponding layout for the circuit. Once our layout is up, we can go to the Scripts menu and choose Global Scripts Run Polyteda LVS. This brings up the Run Polyteda window, which allows us to select the schematic and rule deck we'd like to use for our run. Once the fields are filled in correctly, click OK. LVS begins to run. Once the run is finished, you can see that a results message appears immediately telling you that PowerLVS found 8 errors. You will also notice that a summary window listing the LVS mismatches has appeared in the upper right corner. The areas where the mismatches are reported are highlighted in the layout. For additional debugging information, we can pop up the error file created by PowerLVS. If we investigate the contents of this file, we can see that PowerLVS reported a list of corresponding net pairs in the design and marks 2 of these as shorted nets. Scrolling to the bottom, you can see that the 2 nets in the schematic are being matched to 1 net in the layout. This indicates that the layout net is most likely a short and should probably be 2 separate nets as in the schematic. So let's bring up the LVS errors, the layout, and the schematic all together so that we can more easily navigate and locate the source of the errors. We can now zoom into the schematic and view the area that corresponds to the errant layout section. We can see net 15 highlighted in the schematic. It connects the drains of 2 MOS devices. However, in the layout, the corresponding net is also connected to a nearby resistor. You can highlight the devices in the layout and notice that their matched schematic counterparts are also highlighted. Highlighting the nearby resistor in the layout shows us that the corresponding schematic resistor is not tied to net 15. So it appears that the extra connection to the resistor in the layout is the source of the problem. We can also click on the error report for schematic net 16 and see that it also has an extra connection to the resistor terminal in the layout, which is highlighted. It's clear now where the short exists in the layout, so we can get rid of this offending polygon and then clear the LVS errors to refresh the layout view. Now we can rerun LVS and see if the short has been fixed correctly. Once the run is finished, we see that it's completed successfully with no errors. So now you've seen how to navigate and fix shorted nets using PowerLVS and Analog Office. Now let's look at another common LVS problem, open nets. We'll start again the same way as before by opening a circuit layout. Now that the layout is open, we can go ahead and run PowerLVS. Now that the run is completed, we can see that PowerLVS found 4 errors. And again, you can see the error browser. If we look in the error report yet again, we notice right away that there's an open reported for one of the nets in the match net pairs list. At the bottom, we see the exact net names involved in the open on the layout side, and the single schematic net that matches those nets. Let's adjust our windows again so that we can display the schematic, layout, and the LVS error browser together and make it easy to navigate. You can see in the layout that the offending area of the design appears to be highlighted and blinking. If we click on one of the net errors and zoom in a bit in both schematic and layout, we should be able to get a better look. We can see the devices and the errant net highlighted within the layout. Looking at the list of devices in the error browser, we see that this net is connected to 2 MOS devices and a resistor in the schematic. If we highlight the resistor device in the layout, we can then zoom in a bit to investigate the connections. Upon closer investigation, it appears that a physical connection was never made to this resistor terminal, thus resulting in our open net. We can quickly redraw the route in Analog Office and fix this. Once this is fixed, we can quickly rerun LVS to check our work. Now we see that LVS is completed and the design has no errors. So, we've now shown how open nets can be debugged using PowerLVS within Analog Office. Let's take a look at one final issue, swapped pin connections. As before, we can open up our design layout and set up to run LVS to check the status. We can see that LVS found 2 errors and the offending area is highlighted. If we take another look at the detailed results, it appears that we have a pair of nets that appear to be matched but have different names. As you can see, pin B in the schematic is being equated to pin C in the layout. By bringing up our layout, schematic, and error windows in a more convenient manner again, we can highlight the device in the layout and its corresponding match in the schematic. If we zoom in on these devices, we can see that the schematic pin is B and the corresponding layout pin is C. Seeing that these names are swapped, we should be able to fix this in the layout and hopefully get rid of our errors. Now we run PowerLVS once again to check our work. And we see now that LVS is completed successfully with no errors. So, now we've shown how to debug swap pin situations using PowerLVS and Analog Office. So in summary, PowerLVS is fully integrated into AWR's Analog Office design environment. PowerLVS provides the ability to quickly execute LVS and locate errors accurately and efficiently. For more information on PowerDRC and PowerLVS, please sign up for a suite demo. Thank you very much.